So guys, we're going, guys, your attention. So we're going to start from, I'm going to give a recap of what we have covered from the basics up to where I was so far reached. So that's what I'm going to do with you guys. I'm going to start from what is MATLAB. I realized that during the first few lectures, introductions, most of us were either not around or ready to everything. But yeah, for the guys online, I only see 3 guys online, and we're kicking off official at 3. So in case you guys still have friends that are willing to join, tell them to join in, because once I give today's recap, I doubt if I'll give another recap starting from the beginning. So I encourage your friends to join. For those who can join online, those who can come physically, let them hurry up. So for today, what we're covering, so settle down so that we can start off. So as I said during yesterday's lecture, I'm giving a recap, and I'm starting from the bare introduction. So that is a MATLAB introduction by myself. So what's MATLAB? You may ask yourself what MATLAB is. MATLAB is, as you can check, there is a program for doing numerical computation, originally designed for solving linear algebra type problems using matrices. Hence the name MATLAB, that is Matrix Laboratory. And MATLAB has since expanded and now has built-in functions for solving problems requiring data analysis, signal processing, and optimization, and several other types of scientific computations. It also contains functions for 2D and 3D graphs and animations. So what kind of files do you work with in MATLAB? In MATLAB, you work with .m files, as you see there. You work with .m files. That's an M file may be used as a script that consists of codes, statements. And in addition, you can also use it to create functions. I think for our case, we shall not cover functions. But as you keep on progressing in your knowledge of MATLAB, you'll identify what functions are. But for our case, we shall not use them. So how do you save your work in MATLAB? How you save your work is this, as you can see on the screen there. The command diary file name. So that saves. Okay. Basically, I think for this I will skip it because you know how to save. You have been saving work in Excel, Word, and everything. So there's no need for me to repeat on how to save that. So you guys have always asked for applications of MATLAB. For your case, you only do the first part. maybe you mainly do the first part, which is math and computation, where you carry out normal mathematics, normal mathematical computations, addition, subtraction, and matrices, solving simultaneous equations, all of those. Yeah, all of those. Then as you keep on progressing, you'll start developing algorithms. An algorithm is basically a statement of code that is trying to solve a problem. Yeah, basically trying to solve a problem. And along the way, you'll also hear of something known as modeling, simulation, prototyping. So modeling is what we shall do. Simulation shall do that when we reach Monte Carlo. Simulation, probably in the next time we meet, we shall cover the Monte Carlo simulation. Data analysis, exploration, and visualization. Data analysis is basically you have some data, you want to analyze it to come up with meaningful output so that you can present it out there. Exploration is you're working, you're trying to, let's see, exploration, you're exploring, you're seeing the extent of the data that you have. Visualization, you're coming up with plots, charts. Scientific and engineering graphics, that's, if you have looked at the instruments used in the hospital, you saw those charts that always have they produce something like they produce some weird kind of curves that but I know you have seen them around, scientific and engineering graphics. Then you can also use it in application development apps. Mostly you can use it for developing desktop software. You can also use it for, I think, developing mobile, those are phone apps, and also building a graphical interface and all of that. But for our case, we shall focus on math and computation, and then modeling, simulation, and maybe visualization. Those are the three aspects we shall focus on. So why MATLAB? Why choose to use MATLAB? Because there are various programming platforms out there, Python, MATLAB, C++. So why use MATLAB? One is that MATLAB is a good choice for visual program development. These things you may not be examined on them, but it's just a fresher so that you can get you can get to know what MATLAB is all about. It is quick to learn and good documentation, as you have seen. It's a good library. It has a very good library, excellent display capabilities, widely used for teaching, research in universities and industry. And the last one, that one there, another language to impress your boss with. Yeah. And you can show off out there that, you know what? I know MATLAB. Yeah, so how does code in MATLAB look like? So that is a simple code. So to my left, okay, yeah, to the left, you can see I have A is equals to 1. That is known as a while loop. I'll explain that later on, but for our what we cover, we shall cover a for loop. They're still control statements, but how they work is what's the difference. They can still do the same work. So this one here was to print out Pascal's triangle. You covered that in A-level math, and probably O-level math. So you can transfer Pascal's triangle from math to code, and that's how it would look like. As you can see, we start by printing 1, then the next one is 1, 1, then keeps on 1, 2, 1, 1, 3, 3, 1, something like that. So if you wanted a code to print out Pascal's triangle, that would be it. So that's how code in MATLAB looks like. And I'll share the slides with you guys. I think, yeah, that you guys can always have something to refer to. So still, this is still a continuation of how code looks like in MATLAB. Here we are plotting a simple sine curve. We had t is equals to starting from 0 in intervals of pi over 100 up to 2 times pi. So we wanted to plot a sine function. So this is y is equals to sine into brackets. This is the function we're trying to plot. And the command to plot is plot into brackets t, comma y. Let's see. Okay, the guys online, I only have 9 guys. Guys are physically, I think, less than 30. So encourage your friends to join in. Because next time I don't want to see in the chats that we're not understanding. Yeah, that puts me in trouble. If you guys aren't understanding, it puts me in trouble. So encourage your guys to join in. Still, that is still an example of basically how you write code in MATLAB. So here I was just trying to highlight you what exactly the program is trying to do. So as you can see here, we're still interested in plotting the sine function. But as I told you, everything in MATLAB is a matrix. Is a matrix. So I don't know if you can see the part that says t is equals to 0 in intervals of pi over 100 up to 2 times pi. So what does that do? That creates a 1 by 200 matrix. That's what it does. A 1 by 200 matrix, because we are moving from 0 in intervals of pi over 100 up to 2 pi. So that creates a 1 by 200 matrix. And then what we're trying to, let's see, the argument and result. Yeah, the argument and result is still a 1 by 200 matrix. So that is just trying to show you how MATLAB interprets everything you type in. Everything is interpreted in terms of matrix. Yeah, still that is still a continuation of basically data in matrix is always held as data in MATLAB rather is always held as a matrix. Most cases it is a 2-dimensional matrix. 2-dimensional matrix are, you know, there's 2D and 3D. Yeah? So with 3D, you would put in the 3rd dimension. Yeah? If you go to arrays, I'll show you what 2D and 3D is, in which individual elements are referenced by row and column. So for example, what we have there is a 6 by 10 row column. So there are six rows, 10 columns. So if we head on down, it says if this matrix is given in the name M, then M, assuming you want to access an element within a bigger matrix. So yeah, you guys, you found us an introduction. So just settle down and we continue. So as I told you, we have a huge matrix, which is a 6 by 10, but you're interested in working with one aspect, say one element within a bigger matrix. How do you access that? You access that by, so I'm sharing my, it's more of I'm doing a slideshow, so I can't really edit, but take your attention to where that sentence that says, if this matrix is given the name M, then M into brackets 5 by 4 is equals to 19. So that piece of command is trying to access an element within a broader aspect of a matrix. So 5 by 4 means go into the 5th row and the 4th column. So the 5th row and 4th column, so row 5 and column 4 intersect at 19. So you're able to access that element within that position. Any questions on that? Okay, so I'll keep on moving. So how does the MATLAB interface look like? So that's a screenshot of MATLAB interface. To the top, we have, as you can see up there, we have current directory. Current directory is basically a path to the folder in which you're working in. And then to the furthest left, I have a current folder. Current folder is the folder in which you're currently working in, storing your work, picking your work from. And then to the bottom left, we have M file comment. Don't concern yourself much about the interface, because you can always customize this interface to only show you the current folder, the command window, and workspace. So command window is where your output is displayed. So the command window is both input and output. You can type your code and get your results within the command window. But the challenge is that when you're working with the command window, you won't be able to save your files. Yeah, you can save them, but you can't retrieve them. You can't use them next time. So the best thing that you'll always be doing, you'll have to create a script. We shall see how to create a script. And then to workspace, to my top right workspace towards the current variables you're working with. Yeah, basically that. Command history is, as the name says, all the commands that you have worked with, say, in the command window are always stored in the command history. So next, how do you access help when using MATLAB sales stack? You do not know a particular syntax. You can always use check the second line says help command name. So you type help, that is lowercase HELP, and then you type the command name or function name you're interested in. Say if you're interested in how to create a vector, you simply type help and then vectors, and that is it. So it will produce for you an output with instructions of how to create a vector, the operations in vectors and all of that. Yeah, you can go with the first one. The rest you don't have to cram all of them. Just take the first one, help command name, and then yeah, in case you also want online help, you can go to their website. It's https://www.mathworks.com. Yeah, you can always create an account with them. Sometimes they give tutorials. You can always find some free tutorials on their websites. So what are the useful commands? So the ones in red are basically a common few that I've seen that we may come across. But I'll basically want to put your attention to clear and CLC, because I told you the tests you'll be doing will be objectives. So they could ask you which command you use for clearing the command window. You find CLC, you find clear, you find clear all, clear T. So you must know those simple aspects of MATLAB, of Mathematica. So CLC clears the command window. Clear clears variables from the workspace. So if you had a particular variable you're interested in clearing, you would say clear T. That would clear that particular variable. So I now come to data types and variables. You have been hearing hearing me mention variable data types in probably the previous lectures. So what's a data type? A data type is basically something that tells a programmer the intended use of the data. How are you going to use the data? Are you going to use it as a number? Are you going to use it as a word? Are you going to use it as a character? So numbers, those are from 0 to infinity. Characters, those include alphabetical letters and special characters, such as you have that hashtag sign, you have digital art. So a combination of those letters, a combination of those characters gives a string, which could be words, e.g. your name, your gender, anything. And then what's a variable? A variable is a value that changes depending on the condition. That's how you can basically describe a variable. As the name suggests, it's not constant. So usually we shall have a variable, its value will keep on changing, and then we shall have constants. With constants, their values will remain the same throughout the entire program. So I showed you how to initialize and declare variables. Say in case I'm interested in initializing and declaring my name, a variable called name, I assign it a value, say, Okelo. You see, this is in MATLAB. When I'm dealing with words, basically strings in MATLAB, I put that in single quotation marks, as you have seen that. So those are syntax rules, you must follow them to the dot. Age, you just put the number, there's no need for anything. Say if you have a letter, say a mark, something like that you're trying to declare, yeah, you can put it as A. You can put it as A, two single quotation marks. Sometimes you can also leave it just as A without the single quotation marks. So variable names are case sensitive. And then I give something small on variable names. Okay. So for the guys online, I'll request that you, at the end of the 10 minutes, you will log in using the same link. I'll let you guys in. The guys online. And somebody is asking, pardon, previous slide on clear and CLC. So clear, as I said, clear, when you use the command, it deletes all the variables in your workspace. When you use CLC clears everything within your command window. So in this slide, we are now talking about variables. I say MATLAB can take in up to 63 characters. And then variable names must start with the letter followed by either letters, digits, underscores, anything, but you have to start with the letter. You can't start with a number and then put something. That's not a variable name. Our MATLAB variables are defined by assignment. What I mean by assignment is, say, look at example where I have x is equals to 1. So what I mean by assignment is giving a value to a particular variable. You create a variable and you give it a value. So that process of creating a variable, giving it a value of, in this case, we created x and gave it a value of 1. That entire process is called defining. And how that is done is by assigning a value to that variable. As you can see, you must take note, as I told you, anything is settable with tests. You could be asked what do you use for assigning, what do you use for testing the equivalency of variables. So for assigning, use a single equal sign. That is for the case of assigning a value to a variable. Then the case of equivalency, we shall reach there. I will mention that when we reach there. I do not want to confuse you. So example, the first one is how you define a scalar variable x. So you see, I simply said x is equals to 1, that's a scalar variable. Second, you may declare a row vector, and that's how you create a vector. I'll explain more as we progress with the vectors. The third is how you define a column vector. And then the fourth is basically how you define a matrix. So the difference between a vector and a matrix is basically, I would say, that in terms of dimensions. So with vectors, they have only one dimension. You can either have a row or a column. That's basically it. As in, what I mean by one dimension is that it does not have a vector cannot have two columns. Wait, no, it can. If it's a column vector, it can. So if you have a column vector, it will only have columns. It will have columns and just one row. If you have a row vector, it will have one column and then various rows. But you cannot claim that a row vector has how many? Has two columns. That is not a row vector anymore. That's more of a matrix now. So A is how you declare a matrix, a 3 by 3. So I told you when you're creating a row, you put an element and then you leave a space character. After each element, you can either put a space character or a comma, any of the two. That's how you declare. That's how you create rows. Then how you create columns, as you can see in that column vector, you put an element and then a semicolon. So still, this is still examinable. It could be asked which of the following syntax is the correct way of creating a row vector, a column vector, a matrix. So everything that you see there is still examinable. And then, the last note says that terminate a statement with a semicolon to suppress output. So yes, what's the purpose of a semicolon? To suppress output. All those are suitable objectives you will meet within your first test. You'll tell me the story when you do the first test. But yeah, you'll meet those things. So you must pull up. So next, I'll go to the next slide. Some special variables. Ans, that is the default variable for results. Pi is a value of the mathematical pi that you know. ESP is Yes, P, smallest increment number. I don't care much about it. There's nothing much. I just want to show you some of the special variables that you could come across. So I'll just go on to the next slide and say other symbols. So I'm sure as you have been working with MATLAB, within the command window, you have seen those two arrows coming in before you type anything. Hopefully, you guys have interacted with MATLAB, and you always see those double arrows in the command window, right? So those are to prompt you to enter an input. And then those dots there are basically continue statement onto the next line. You may not use it that much. And then a comma is to separate statements, separate data. You can also use it when you're creating row vectors, when you're creating a row in short. Then the percentage sign is used to comment. So what's the purpose of commenting? Purpose of commenting is leave behind instructions. That is still examinable. What's the purpose of a semicolon? 1, to suppress output. 2, used as a row separator. Yeah, a row separator in a matrix. It can also be used as a column separator in a vector. And then full colons are used to specify a range. As you could have seen when we are working with a for loop, you have that for I is equals to 0. You always saw me putting full colons. So I had something like 1 full column, 2 full colon, 20. So that means that move from 1 intervals of 2 up to 20. But in case I not put an interval and I say move from 1 full colon 20, that means that just come from 1 to 20 in a default interval of 1. That's all. I'll do them practically. These are basically rules. So I'll do the rules theoretical and then do everything practical as you keep on moving. So relational operators. So much as you have the grammatical and English, basically grammatical operators, less than, less or equal to, greater than, greater or equal to, and not equal to. That's how they're represented in MATLAB. Less than, you're aware of that. Less or equal, you're aware of that. Greater than, what you meant to be aware is that, as I told you, the equivalent of the equal to in MATLAB is those double equal signs. And then when you're trying to say that something is not equal to, you put that, I do not know how that sign is called. Yeah, you put that and then you put equal to. That sign, yeah? Something like that, yeah. So that is the equivalent of not equal to. That sign and then single equal to. So I'll go on to the next. So what are some common math operators? As you can see there, for power, you use that sign there. Say if you had something to the power, as you can see, to your up here I have power. It can either be this or this. So when I put a to the power b, it is something like that, or it can be a dot power b. I'll explain what this does. This is element-wise operators. So as I said, I'm going to go through the rules and do everything practically, what I've so far discussed. And we shall meet them as we cover matrices, cover vectors. So the guys online, you have less than 1 minute, but after that you can log in using the same link. So yeah, you have multiplication, you use asterisks, or if you're multiplying, say two matrices, and you're not interested in row by column multiplication, just interested in multiplying one element by another element. I will show you that once we reach our matrices. And then division, you're aware of that. Multiplication, addition, subtraction, assignment, I told you. A is equals to B, you're assigning B to A. Basically, when you're dealing with variables, you're assigning. Then next, logical operators. Logical operators, as you always have your logical reasoning of equal to, those ones you have covered them.